Oh, and welcome to class. Okay, so we are jumping right in with solving equations involving absolute value. And here we go. Just starting off with a quick review about what absolute value is, just so that we're all on the same page and we understand it. Somebody tell me what absolute value means. Sean. It can be, we can do absolute value involving decimals and fractions and stuff too, so it doesn't have to just be a whole number, as you said, RJ.
How far away it is from zero?
That's exactly what absolute value is. Absolute value is a distance measurement. How far away from zero is that number? And the thing about distance is we always measure distance using what type of numbers? That's kind of an obscure question, maybe if you're not thinking along the same line. Jackson. Whole numbers, maybe. I can go a half a mile. Doesn't have to be a whole number. Henry?
Usually positive.
Yes, positive numbers is what I was looking for. Thank you. And that, like I said, that wasn't maybe the greatest question, but you caught on. You got me. So we always measure distance in positive numbers. For instance, I wouldn't tell you that last night I drove 30 miles to Salina, and then after I did my shopping, I drove negative 30 miles home because I was going the opposite direction, right? We measure both directions using positive numbers. So if I want to talk about how far away from zero is the number 5, if I'm standing at 0 and I want to walk to 5, how far do I have to go? I have to go 5 units, right? Well, hello, Google. All right, thank you. Okay, so if I'm at 0 and I want to walk to 5, I need to walk 5 units. It's 5 units away. But if I'm standing at 0 and I want to walk to negative 5, how many units away is that? It's also 5 units away, okay? So we don't care about which direction it is or that we're moving in the negative direction. We just care about how far is it. That's all we care about with absolute value. What symbol do we use for absolute value if I want to know the absolute value of 5? 2 lines on each side of it. And I'm not sure if, well, I just always call those absolute value brackets. We treat them like parentheses when we get to operations here in a minute. Do things that are inside the brackets first and then perform the absolute value itself. So absolute value of 5 is 5, but the absolute value of negative 5 is also 5. So I like this discussion. You guys seem to understand it's a measure of distance. Sometimes I have people want to explain that the absolute value brackets change the sign of the number or do something, and that's not what they do. They're not. It's not changing the sign of a number because it doesn't change the sign of a positive 5. All it's doing is measuring that distance. Okay. Oh, look, I didn't even know I had 5s already chosen. So the absolute value of 5 is 5. The absolute value of negative 5 is positive 5. So all we're doing is measuring that distance away from 0. Okay. So now we can evaluate if x equals negative 5. We can tell me if your notes start to vary from mine a little bit. I know I made some changes, and I'm not sure I opened the right slideshow, but I made a change to a slide or two as we go through, and I hope I opened the right slides. So we do what's inside the absolute value brackets first, and then we perform the operation of the brackets themselves. So we need to substitute negative 5, keep the plus 2 there, and then plus 5. So now we perform the operation first. Negative 5 plus 2 would be negative 3. Make sure your brackets don't look like 1s. Sometimes mine struggle. And then plus 5. So absolute value of negative 3 would be positive 3 plus 5, so that's going to be 8. Everybody with me? Any surprises so far? Okay, so absolute value of 4 plus negative 5 minus 9, so that would be absolute value of negative 1. 4 plus negative 5 is negative 1 minus 9, which would be 1 minus 9, which is negative 8. Okay, so those are pretty straightforward. I know you guys have seen those before. Don't think there'll be any difficulties there. Now, what about this? If you know, if we have to solve for x, and I tell you that the absolute value of x is 4, what can you tell me about what x is? Henry?
Well, it's 4, whether it's negative or positive.
Yes. So what is my possible solution for x?
Negative 4.
Okay, so when we have more than one possible solution, how do we write our answers? What do we call this?
Oh, it's set.
Set notation. So negative 4, positive 4. X could be negative 4, X could be positive 4. And if you have to do some graph, I can't remember on today's, I don't think we even have to graph on today's assignment, but I've included it in the notes because sometimes they want you to graph the solution. So negative 4 and positive 4, plus it's going to set up what we're doing tomorrow. So negative 4, positive 4. So we would just graph those 2 points on the number line, showing that there are two numbers that are 4 units away from 0. Okay? So, believe it or not, part of your assignment today is doing these right here. And you know what? We're going to go ahead. We will do a little bit of graphing today. So what's my solution set here? Y equals? It's that easy. Negative 17 and positive 17. Drawing the brackets is the hardest part there. If you need to draw a number line and don't have one, you know I like simple number lines, so I want a 0, I want a positive 17, and I want a negative 17. You don't have to I don't have to number 1 through negative 16 here, okay? So if you need to draw a number line to graph these kind of things, then that's all I would want to see. Very simple. K equals 2, our absolute value of K equals 2, so K equals negative 2 and positive 2. All right. Have I done anything scary so far?
No.
Good. All right, let's keep it that way. Well, we're getting there. Okay. All right. You might have to do some steps so that you can solve for x. Okay? We might have to throw some operations in there. In this case, absolute value of x plus 2 equals 3. So what do? Just subtract 2. And then the absolute value of x equals 1. So x equals negative 1 and positive 1.
So, that's all the steps, right?
For this example, that's all the steps.
Is there a way to show your work about any like? Because I'm confused. I'm not confused. I just don't know if I'm
There's nothing else you can show. I mean, this isn't that much. It's one step to get the equation balanced, and then you show what the absolute value could be. I mean, there's really only 2 steps here. Then you write your answer.
It just looks like
There's going to be more steps when we move a little further. At our next section, we're going to have more steps, I promise. So we would graph that at 1 and or negative 1 and positive 1. Simple enough. Okay, so add 4, absolute value of r equals 12. So r is negative 12 and positive 12. Don't forget the brackets, guys, like I almost did there.
Does it matter what order you put?
I mean, you can write a set in any order you want. Typically, numeric order is just easier, I think, to interpret it and to read it. But as long as everything you want is inside those brackets, then that is the set and it's okay. So I won't, if you put them positive 12, negative 12, I would not count it wrong. All right, so we don't have a number line there that goes to 12, so I'm going to make one, negative 12, 0, positive 12. Okay, moving right along. I don't think do you have this slide?
No.
No, okay, skip it. All right. You got this one?
Yeah.
Okay, this is the one I wanted to go to. All right, that's what I was thinking, that I deleted that last one because it wasn't particularly helpful. Here Here we need to change gears a little bit because this is a different type of equation, because whatever is inside these brackets, we've already talked about. I mean, if I go back a slide here, whatever x is, it could be a negative number or it could be a positive number, right? It could be -1, it could be +1. So whatever is going on here inside these brackets, when I'm done adding n and 1 together, whatever n is, it could have started out as a negative number and ended up as -3 to become this, or it could have started as a positive number and add them together, and then it comes out to be +3 to get this, right? Catch what I'm saying? We've got to have two solutions. We've got to have two possible answers. And now, because everything is inside the brackets, we've got to show what both of those answers could be. And so we're going to do two steps. And we're actually going to call it case 1, and that's case 1. That's a 1, not an L. It always looks like casel. Okay, case 1, and we're going to do case 2. Okay, so here's how you solve case 1 and case 2. Case 1, we're just going to take the equation that's inside the absolute value brackets and leave it just like it is, n plus 1. Notice I didn't write the brackets. I don't need the brackets to do case 1. N plus 1 equals 3. Subtract 2. What? Subtract 2? Why would I do that? Because I'm thinking of what the answer would be. Subtract 1, and n equals 2. You with me? That makes sense? So what do you think case 2 needs to look like? N plus 1 equals, what could the inside of my brackets be? -3. So n plus 1 equals -3. Because think about it, if I have this, I want this to either come out to be, the absolute value of -3 equals 3, or I want it to be the absolute value of +3 equals 3. Does that make sense? So I've solved this one. Now I need to solve this one. So I need to do n plus 1 equals -3, subtract 1, n equals -4. Okay, so we've got two solutions for n now, and both of them give me a 3 absolute value. -4 plus 1 equals -3, so my absolute value is 3, and then 2 plus 1 equals 3, so the absolute value of 3 is 3. So n, my solution set now looks like this, -4, 2. And then I would graph it thusly. Okay? Have you done these equations before? Okay, so this is the new part that I was telling you. I thought we'd do something new today. I figured you had done everything up to this point, but this is where it gets new. Okay, f plus 3, and I think I changed the notes. Okay, so f plus 3 equals 5. So I've got to do two cases. Case 1 is f plus 3 equals 5. I just always start with the positive because everything stays the same. Okay, so f plus 3 equals 5, subtract 3, so f equals 2. And then case 2, f plus 3 equals what? -5. Subtract 3, so f equals -8. So then my solution set, and yes, I want you to write the solution set. Don't just leave it as these two solutions. Write your final answer as the solution set. -8, 2. And then if you have to draw a graph for these, same thing. I want -8 to be down here, and I want 2 to be up here. Now where does 0 go? Right in the middle? 0 goes up here. Okay? So that's the way I would want that to look for a number line if you have to draw it. Okay? You have one more?
Yeah.
Okay, then I'm going to add one. G minus 5 equals 13. So, case 1, G minus 5 equals 13. Add 5. G equals 18. Case 2, G minus 5 equals negative 13. Add 5, so G equals negative 8. Solution set, negative 8 comma 18. Number line, negative 8, 18, 0 would be, somewhere in there maybe. Okay, there's one scenario that we need to talk about that I left out of the notes, but I thought of just now. So, what if, well, let me just give you a new one. Absolute value x plus 4 equals negative 2. Does anything change with this one? Jeremy? Yep, the answer it equals is negative instead of positive. So would we just solve it still case 1, case 2?
Yeah.
Okay. So oops, I don't need the absolute value. X plus 4, oops, I forgot to, got it right, case 1. What's up? I can't hear you. It's a 2, sorry, negative 2. Yeah, I shouldn't use some values. So equals negative 2. So subtract 4 equals negative 6. Oops, my goodness. Sorry, minus 4, and then x equals negative 6. Okay, and then at case 2 would be x plus 4 equals, so we just change the sign then? Change it to positive 2? Okay, so subtract 4, x equals negative 2. Okay, is everybody okay with this? I'm going to give you a second to think about that. Maybe you'd like to change your minds about being okay with it.
Well, negative 2 is better than
They're both negative, but you can still put the 0 over on there.
Absolute value. Absolute value means what?
Well, how could that?
Henry's got a thought. I can feel it.
How could that be negative?
How could it be negative? If the absolute value of whatever's inside these brackets, if whatever's inside these brackets is absolute value, how can it come out to be a negative? It would be like, can I do this? Can I do the absolute value of x equals negative 2?
No.
Yeah.
I mean,
No, that's equal.
It has to equal a positive number. Absolute value is always a positive number because we're talking about a distance. Sean,
What's happening is the additive is bigger than the actual number, which makes it negative all the time.
but this one can't be true. X can't equal, absolute value of x can't equal a negative 2. So can this one be true? Jackson,
No.
it can't be true. This is a no solution. Okay, I know I just put you through all that work, and because I wanted you to think about it, I wanted you to see it. If I don't have to do any of this. At this point right here, if you see it, you ever see those memes or whatever? When you see it, when you see everything inside the absolute value brackets and then it equals -2, automatically it's no solution. Can't do it. Okay. Now, if there's anything else going on outside of the brackets, we need to take some steps. I mean, if I'm gonna erase all this. If we had, x plus 4 absolute value minus 37 equals -4. Okay, now we've got to take some steps and solve it because we can add 37, right? We would do that first because it's outside the brackets. Then I would have x plus 4 equals 33. Oops, absolute value of x plus 4 equals 33. Now we can do case 1 and case 2 because that comes out and works right. All right, so as long as you have only absolute value brackets, you should have a positive solution. Okay, your assignment is right back here on my table, and right there. Grab one of those. Yes, do them all. Hold on just a second. Let me.